name is Obiombo Olusegun. I'll be teaching you with online algebra. What is algebra? Algebra is the part of mathematics in which letters and general symbols are used to represent numbers and quantities in formula and equation. Let me put the definition on the board so that you can see it. So that is the definition of algebra. That is the definition of algebra. Now, in algebra today, we are going to discuss about, I think you have seen the formula very well. Okay, so we are going to talk about in algebra today, we are going to talk about operation of real numbers. We are going to talk about operation of real numbers. Operation of real numbers and their subsets. Operation of real numbers and their subsets. This is what we are going to talk today. But before that, you need to understand what a set is. A set. A set is a collection of objects. A set is a collection of objects. A set is a collection of objects. Now, example, a set is equal to 1, 2, 3, 4, 5. So that is a set. Now this pair of braces that you see here describe the members of the sets. This pair of braces describe the member of the sets. And what are the members of the set? The members of the set are 1, according to our example, the members of the set are 1, 2, 3, 4, and 5. These 3 dots indicate that the pattern still continues. These 3 dots indicate that the pattern still continues. Now, these numbers that we see here, 1, 2, 3, 4, 5, means the natural number or positive integers. Natural numbers or positive integers, which are still subset of real numbers that we are talking about. This is what we call natural numbers. Natural numbers or positive integers. Positive integers. Natural numbers or positive integers. So these numbers that you see here, we deal with them on our day-to-day encounters, day-to-day activities, but they are incomplete without having 0. Most of our transactions are also deal with 0, but with the example, the example I gave above, without 0, automatically the transaction is not complete. So if we want our transaction to complete, or want to describe the above description completely, we need to expand it to include 0. So we have to put our 0 here. So with this 0 here now, this is what we call whole number. It now becomes whole number. Whole number. Whole numbers. Whole numbers. Now, our activities are not still complete with the whole numbers alone. With the whole numbers alone. With the whole numbers alone. Because there are a lot of negative activities that we also encounter in our runnings, in our day-to-day activities. That is why we need to expand our whole number. We need to expand our whole number. We need to expand our whole number to include, we need to expand our whole number to include negative numbers, which are called negative integers. Negative integers. And what are negative integers? -5, -4, -3, -2, and -1. This is our negative integers plus our whole number. Now we now have what we call sets. We now have what we call set of integers. Set of integers. We now have what we call set of integers. But with this set of integers, this set of integers are the subsets. This set of integers are the subsets of real numbers. They are also subset of real numbers. They are subset of real numbers. That's why when you have set of integers, you also have real numbers. Set of integers are subset of real numbers. But the daily transaction, daily encounters, whatever you do with figures are not still complete with only set of integers. So we need to expand it, because most of our other transactions still deal with either the parts or the decimal. So how do we do that? Let's say, for example, you work in a particular place for just 2.5 hours, or you work in a particular place for just 3.5 hours. How will you explain that with just set of integers? Automatically, we need to expand our set of integers. We need to expand our set of integers. We need to expand our set of integers. So we need to expand our set of integers to include fraction. We need to expand our set of integers to include fractions. And what are those fractions? Those fractions, we need to expand it. Expand to include fractions. We need to expand it to include fraction. And what are those fractions? We have two fractions that we have to include. One rational number. Rational numbers. Two irrational numbers. Irrational number. So those are the two fractions that we need to include in our set of integers to make it a complete real numbers that we have been talking about. What is the rational number? What is rational number? Rational number rational number rational numbers are numbers that can be written as ratio as ratio of two integers. Rational numbers are numbers that can be written as ratio of two integers. Example: example of rational numbers. Rational numbers. 2/3 is a rational numbers. 3/5 is a rational numbers. 2/8 is a rational numbers. These are the rational numbers. What is irrational numbers? What is irrational numbers? What is irrational numbers? Irrational numbers are numbers that cannot be written as two integers. So you can see irrational numbers are numbers that cannot be written as two ratio of two integers. Irrational numbers are numbers that cannot be written as two ratio of two integers. That is irrational number. Example of irrational numbers. Example of irrational numbers, like square root of 4 is irrational numbers. Square root of 16 is irrational numbers. Square root of 8 is irrational numbers. Then pi is irrational numbers. So these are irrational numbers. So with our rational numbers and irrational numbers, with our set of integers, we now have complete real numbers. We now have complete real numbers. We now have complete real numbers. There is something I also want you to understand, which is how decimal representation of a rational number is terminating or repeating. How the decimal representation of irrational numbers is terminating or repeating. For example, the decimal representation of 1/4. Decimal representation decimal representation of 1/4. Decimal representation of 1/4 is equal to 0.25. So like this one now, this is terminating. Rational numbers can be terminating or repeating. So this example now, this one is terminating. This is terminating. This is terminating. So the decimal representation of, let me give you another example of repeating decimal number. So this decimal representation of 4/11 is repeating. So 4/11 is equal to 0.36 and on like that. It will continue like this. That is the decimal representation of a rational number. The decimal representation of a rational number can either be terminating or repeating. So this is example of terminating decimal number, which this one is example of repeating decimal numbers. So that is it. So now let's go to the decimal representation of irrational numbers. Decimal representation of irrational numbers. Decimal representation of irrational numbers. Decimal representation of a rational number are decimal representation of irrational numbers are neither repeating neither repeating nor decimal representation of irrational numbers are neither terminating nor repeats. For example, 2 over we can go for today. Thank you very much. If you have been really blessed with my video, please kindly subscribe to my YouTube channel. Kindly subscribe to my YouTube channel and my Facebook page. Please comment on my video, share my video, like my video. As you do so, God will bless you. God will bless your home. God will bless everything about you. Thank you very much.